What's up, guys? So we're going to be talking today about rational function characteristics and how to graph a rational function. So a little note heavy here, and feel free to pause the video to write any of this down. We've already talked about a lot of this. So the zeros or the roots or the x-intercepts of any function, but including a rational function. In the case of a rational function, those are the things that make the numerator zero. Okay, going back to one of our examples from before, whatever makes that number on the top zero, that's going to be a zero of the function. It's an x-intercept, it's a root. These all mean the same thing. Things that make the denominator zero, we call those undefined. Sometimes we call those excluded values, extraneous solutions, potentially. Vertical asymptotes is another thing we're talking about now. When we graph these, a vertical asymptote happens where it's undefined, which is what makes the denominator zero. The new thing we're talking about now is the horizontal asymptote. And you saw that when I showed you that graph in the last video. This one here, you see we talked about the vertical asymptote, and I kind of didn't mention the fact that there's a horizontal asymptote here as well. And that horizontal asymptote has some rules, okay, for determining what that is. It's a horizontal line, and it's going to be, for you guys, it'll be one of two things. And there's three cases on here, but it'll only be two for you. So there's three cases. If you have a polynomial divided by a polynomial, that's a rational function. You have a polynomial on top and a polynomial on the bottom. A and B are the leading coefficients. N and M are the powers of the highest power terms. So in other words, the degree. The degree is N for the top and it's M for the bottom. Based on the degree is going to determine how you find the horizontal asymptote. If the degree is higher on the top, if it's lower on the top, if N is less than M, if this has a lower degree than the bottom, then the x-axis is the horizontal asymptote. You'll have a horizontal asymptote on the x-axis. And we'll graph some in a minute to see how this works. If the degree is the same on the top and bottom, if n is equal to m, then the horizontal asymptote is the line y equals a divided by b. So you would actually divide this leading coefficient by that leading coefficient, and whatever you get, that is actually where the horizontal asymptote is going to cross. And finally, the last case, and we're not going to actually deal with this case in class, but just so you're aware, there is a third case where the numerator has a higher degree than a denominator, and you actually don't get a horizontal asymptote. What you get is what's called a slant asymptote. And just, a quick sketch. It might look something like this. So here's your axis. You might have a graph that goes like this, and then maybe it goes like this. So there's actually a horizontal, there's a diagonal we call a slant asymptote. But for you guys, these two cases are what we're going to be focused on. All right, so here's an example. So it says sketch a graph, state the zeros and asymptotes, if any. So I'm actually going to do that part first. Let's actually write out what would be the zeros of this. The zeros are what's going to make the numerator zero. So you can either set this equal to 0 and solve it. I'll go ahead and do that. You can say, you can go off to the side somewhere. You can say 2x plus 2 equals 0. A lot of you probably know what the 0 is already. Subtract 2 from both sides. So x equals -1. Okay, so the zeros are just -1. If I plug in a -1 here, I would get a 0 in the numerator. The denominator, what I usually call the excluded values, if you want to, we can start calling that now vertical asymptote. Means the same thing. The vertical asymptote is going to happen at 3, okay? Specifically, it's the line x equals 3. If you just say 3, that's fine, as long as you know what to do with it. Okay, so to do a sketch, the numbers here are pretty small, so we only need to go a few units in each direction. Try to equally space it as much as possible. Okay, doesn't have to be perfect, just try to do your best. Okay, there's a 0 at -1. What does that tell me? Well, that means there's a point right here. That's actually going to be the x-intercept, or an x-intercept, the only one for this graph. There's going to be a vertical asymptote at 3, so I like to put a dotted line there. A vertical dotted line at 3. Okay, and so now we have to think, what's the horizontal asymptote? Remember our rules. The degree is the same. If the degree is the same, then the horizontal asymptote is the line y equals a divided by b. So the horizontal asymptote is going to be 2 divided by 1. Y equals 2 divided by 1, which is really just 2. Okay, so there's a horizontal asymptote at 2. I'll put a dotted line that way. Now, a lot of times the graph is either going to look like this. It's going to go like this way and this way, or maybe it'll go this way and this way. Well, since we have the x-intercept here, that's a pretty big hint of what this graph's going to look like. Now, if you want to, you can plug in some other test points as well to get kind of an idea what the sketch is going to look like. But if it's a quick sketch, I'm okay with just doing this, because here's what we know. We know that it's going to cross through this point, and it's going to approach these asymptotes. Now, maybe it curves out a little more or a little less. I'm not too concerned with that level of accuracy at this point. It did say sketch. I've got a point that tells me which quadrants we're in, sort of, and this is just going to go like this. And as long as you've got something like that, I'm okay with that. Okay, you can see that it's approaching the asymptotes on both sides, and I've got one test point. If you'd like to plug in some other values for x and get some other values for y, you can plot those points. You can even type it in a graphing calculator and take a look at it if you want to. The main thing I need to see is I need to see asymptotes in the 0, and then I need to see those graphed on here. Okay, and one more example. So again, let's start out by identifying what the zeros are. What can I plug in for x that would make the numerator 0 here? None. There's nothing. There is no x in the numerator, so there's nothing I can plug in that would give me a 0 in the numerator, which means this graph is not going to cross the x-axis. Vertical asymptote, -1. Or you could say x equals -1. If you just want to say -1, I'm okay with that. And the horizontal asymptote, going back to our rules, in this case, the degree is larger on the bottom. The bottom has a larger degree, so we're in this first case. That means the x-axis is the horizontal asymptote. Okay, so it's just going to be, since it's the x-axis, it's just going to be y equals 0. Okay, so let's just plot what we have. Now, I don't have an x-intercept this time. I have vertical asymptote at -1. And a horizontal asymptote at the x-axis. So it's on the x-axis here. Okay. Well, now I've kind of got a problem because I don't know, does the graph go like this or does it go this way? So I'm going to have to use some kind of test point. So what would be a good number to plug in? How about the number 0? Say if I were to plug 0 in here. Imagine if I plug in a 0. That's going to leave me with just 5 over 1, which is 5. So if I plug in a 0, I get out a 5. 1, 2, 3, 4, 5. That would be a point in the graph. So already you see kind of where the graph's going to go. Okay, plug in another number. Say you plugged in a 1. That'd be 5 over 2. 5 over 2, which is 2.5. So at 1, the graph is at 1, 2.5. And this is how test points work. You can plug in as many as you want. Maybe plug in something over here. Maybe plug in a -2. If I plug in a -2, that's going to give me -1 on the bottom. And this whole thing is going to be 5 over -1, which is -5. 1, 2, 3, 4, 5. At -2, I get a -5. So that would be a point down here. And you can keep going. If I plug in a -3, that'd be 5 over -2, which would be -2.5. So go over -3, 1, 2, 3, go down 2.5 right here. And you don't really need this many test points, but it's just kind of give you an idea what the graph looks like. And just draw your curve where it's approaching the asymptotes and it's passing through those points. Something like this. Okay, I've identified the zeros, which there's none, the asymptotes, and drawn my curve.